Okay, today's lesson, guys, is we're going to take a look at coin problems, another type of problem that gets you a type 3 or 4 linear equation. All coin problems basically look the same. They have this format. You end up where you have to multiply the value of a coin by the number of that coin that you have, and then add it to the value of a different type of coin times the number of that type of coin that you have. And all of that's always going to equal how much the total value of the coins is. Here's a simple example to start us off. Two bags contain the same number of dimes as nickels. If the value of the coins in these bags is $2.85, how many nickels and how many dimes are there? So, like most word problems, I have to define my variable. And when it says same number of dimes as nickels, it doesn't matter which one I call x. I'll let x equal the number of dimes that I have. And when I say dimes, I should maybe write that better. It's not just x equals dimes. X equals number of dimes, like 1 dime, 2 dimes, 3 dimes, 4 dimes, etc. Since it's the same number of dimes as nickels, then x also represents the number of nickels I have. So it doesn't really matter which one I call x. So you might be wondering, well, then how do I know which one I'm solving for? Well, at the end of the day, it's going to be the same number for both of them. But when I make my equation, here's what changes about these two input numbers here. They have to together equal $2.85. I'm going to just change that to 285 cents so that I'm not working with a decimal. Right? Think $2.85 since there's 100 cents in every dollar. That's 285 cents. And what I know is that every single dime that I have is each worth 10 cents. And every single nickel I have is each worth 5 cents. So think about it this way. If you have 1 dime, you have 70 cents. If you have 12 dimes, you have 120 cents. If you have X dimes, you have 10X cents. Think about the logic of that. Why is that true? Same thing with the nickels. If I have 1 of them, I have 5 cents. If I have 7 of them, I have 35 cents. If I have X of them, I have 5X cents. 10X cents plus 5X cents is 285 cents. That's the way that we do this equation. Those are alike terms, so I add them. And I believe this goes into here, I want to say 19 times. Can somebody double check that? I think that's right. Divide both sides by 15. And I get 19. Now, what does that number represent again? It represents both of those numbers. So my conclusion statement would be something like, therefore, the bags have 19 dimes and 19 nickels. And a quick check to see if that works. 20 dimes is $2, so 19 is $1.90, and 19 nickels is 1 short of $1. Add those two numbers together and you get $2.85. So that's how you do a simple one. Here's one that's a little more complicated. It's got an extra trick to it, but this trick happens in algebra in a lot more places than just number problems, so it's a good trick to know. A man has dimes and quarters worth $9.50. He has 50 coins in all. How many dimes and how many quarters does he have? It doesn't tell me how many of the 50 are dimes and quarters. So how do I figure out which one to go? Like, can I call them both X like I did in the last problem? No, if I call them both X, I'm assuming I have the same number of each. It doesn't say that. How do I then set my variable? Well, this is the key idea here. There's 50 coins in all, and there's only 2 types. The 2 types are dimes and quarters. So let's just kind of role play this for a sec. There's you. Let's say that I gave you 50 coins, and in this hand I'll put the dimes, and in this hand there's 10 dimes. How many quarters would you have in this hand? 40. What if we had 20 on this hand? How many's in the other hand? 30. Let's try a tougher number. What if we had 17 in this hand? We'd have 33 in the other hand. Okay, you're getting the idea. So now, what if I had X of these? What's the other number? It can't be X. Are these numbers always the same? I heard somebody say it. This hand would be 50 minus x. Look at how those numbers all matched up. 10 becomes 40, 20, 30, 17, 33. How are those numbers all related to each other? They add up to 50. So whatever number this is, this number has to be 50 minus that number, or else they wouldn't add to 50. That's the trick I'm going to use to make my equation. So I have 50 coins in all. I'll let x equal dimes, or again, number of dimes. Okay? That means that the number of quarters, logically, has to equal 50 minus x. Now we build the equation the same way we built the last one. How much are the dimes worth? Well, each one of them is worth 10 cents, so 10x is how much my dimes are worth. Quarters are worth 25 cents. How many of them do I have? 50 minus x of them. So 25 times 50 minus x is the total value of my quarters. And all of that equals 950 cents, the total amount that the coins are worth. So this one requires an extra step. I have a distributive property. 25 times 50 is 125 with a 0. 25 times negative x is negative 25x. I'm going to collect those two like terms there and there. So that's negative 15x plus 1250 equals 950. Don't panic about the fact that my x has a negative on it right now. It won't stay that way. It better not. How do I have negative of something coins? But I can see already that it's going to cancel. I'm going to minus 1250 from both sides. And what kind of a number will I get on the right-hand side? Oh, it'll end up negative. So what is 1250 minus from 950? Well, let's see. 50 minus 50 is 0, 0. 12 minus 9 is a 3. So I have negative 300. And how many 15s go into 300? 200? How about 20? So here we go. X is 20. Now, what did X represent again? Go back to the top of my problem. X represented the number of dimes. So my conclusion will then say, therefore, I have 20 dimes. Okay. But I need to figure out how many quarters. What do I do again? Go back to there. I should have 50 minus the 20. So therefore, 30 quarters. And a quick check to see if that adds up to 950. That's $2 in dimes. 30 quarters. How much is 30 quarters? I got to think about that. If I have 4 quarters, I have $1. So that's $6.50. No, $7.50, which makes 950. Yay! And that's how you solve coin problems.